This slide introduces Domain 5, focusing on Identity and Access Management, IAM, within the CISSP Certification Course. Specifically, we will be exploring Role-Based Access Control, RBAC. RBAC is a pivotal aspect of secure identity management, involving the implementation and management of user roles and permissions. This helps in ensuring that users have appropriate access levels based on their roles within an organization. On this slide, we're focusing on Role-Based Access Control, commonly known as RBAC. RBAC is a foundational component of secure identity management systems. The main objective here is to understand how to implement and manage RBAC effectively within your organization. RBAC is important because it centralizes the management of user permissions within predefined roles, simplifying access control and reducing the risk of unauthorized access. Through this method, we can streamline administrative tasks and ensure that users have the necessary access aligned with their specific roles. Role-Based Access Control, or RBAC, is a fundamental concept in secure identity management. RBAC defines access permissions based on roles within an organization. Rather than assigning permissions to individual users, we assign roles to users, and the roles carry the needed permissions. This way, users inherit permissions only for the roles they are assigned to. This method simplifies management and enhances security by grouping permissions into roles instead of handling permissions on a user-by-user basis. In this slide, we focus on several key concepts essential for understanding role-based access control, RBAC. Firstly, the principle of least privilege ensures that users only have the minimum access necessary to perform their role. This minimizes security risks by limiting unnecessary access. Next, we look at separation of duties. This concept involves dividing critical tasks among multiple roles to prevent fraud and errors. For example, in a financial system, the role of entering payments should be separate from the role of approving those payments. We also discuss role hierarchies. In RBAC, roles can inherit permissions from other roles, allowing for a structured and scalable permission management system. For instance, an admin role can have all the permissions of manager and employee roles, plus additional administrative privileges. Overall, understanding these concepts helps in creating a more secure and organized role-based access control system. To effectively implement role-based access control, RBAC, we need to follow a systematic approach. First, identify the necessary roles and their corresponding permissions. This involves understanding the functions and access levels required for each role within your organization. Next, create these roles within your system, ensuring that each role's permissions accurately reflect its responsibilities. Then, assign users to these predefined roles, aligning their access with their actual duties. Finally, it is important to regularly review and update both roles and user assignments. This ongoing process ensures that access permissions remain appropriate and secure, adapting to any organizational changes or evolving security needs. Let's now look at an example tool for managing role-based access control, RBAC. Windows Server. In this context, we use Active Directory to enforce RBAC. Active Directory allows us to manage roles and permissions effectively. One key command we can use here is net local group. For instance, if we want to create a role group for HR managers, we would use the command net local group HR managers/add. Once the role group is created, we can add users to this group. For example, to add a user named Danielle to the HR managers group, we would execute net local group HR managers Danielle add. These commands help in streamlining the process of assigning permissions and ensuring that the right users have access to the right resources. In this slide, we'll focus on managing role-based access control, RBAC, within a Linux environment. One common tool used for this purpose is sudo. By editing the sudoers file, you can specify which users are granted elevated privileges and what commands they can run. For instance, to grant a user named sudo-user all permissions, the entry would be sh sudo-user all. This means that sudo-user can execute any command as any user on the system. On the other hand, if you want to restrict access to specific commands, you can refine the entries. In this example, we restrict a user named secure-user to only run apt-get, secure-bit isap-bind apt-get. This ensures that secure user can't perform unauthorized actions beyond what is explicitly allowed. It is essential to carefully manage these settings to maintain security and functionality in your environment. On this slide, we'll cover best practices for managing role-based access control, RBAC. First, conducting regular audits is essential to ensure that roles and permissions are current and appropriate. Next, always maintain comprehensive documentation of roles and access levels to improve transparency and ease of management. Automation can help streamline the process of assigning roles, reducing the chance of manual errors. Lastly, it's important to provide consistent training to ensure that all users understand their specific roles and responsibilities within the system. These practices help create a secure and efficient RBAC environment. In this real-world scenario, we examine a large healthcare organization to illustrate how role-based access control, RBAC, can be effectively implemented. Here, roles are clearly defined to ensure secure and appropriate access to sensitive information. Doctors have full access to patient records, allowing them to provide comprehensive care. Nurses, on the other hand, have limited access tailored specifically for caregiving tasks, which maintains patient privacy. Administrative staff are given access to billing systems, but are restricted from patient records to protect confidential medical information. To ensure the system remains secure and compliant, regular audits are conducted. These audits help verify that access permissions are current and that there are no violations or security lapses. Additionally, the principle of separation of duties is applied to mitigate risks. This means no single role has conflicted permissions, ensuring, for instance, that someone with administrative access to billing doesn't also have access to patient records. By adhering to these best practices, the organization can maintain a secure and efficient system that protects patient information while allowing staff to perform their duties effectively. Now, let's discuss some common challenges you might face with role-based access control, RBAC, and their solutions. One challenge is role explosion, where the number of roles can become unmanageable as you try to accommodate various access needs. The solution here is to use role hierarchies to streamline the role management process. By establishing parent and child roles, you can simplify the structure and make it easier to manage. Another challenge is static role assignments, which can lead to inefficiencies and potential security risks. To counter this, implement dynamic role assignment tools that adapt to the changing needs and contexts of your users, ensuring that access permissions are always current and appropriate. Lastly, we have role creep, where users accumulate unnecessary permissions over time. This can be mitigated by conducting regular role reviews and audits. By routinely checking and adjusting roles, you can ensure that users only have the access they need and nothing more. These strategies help maintain a secure and efficient RBAC system, ensuring that each role aligns with organizational and security objectives. On this slide, let's summarize the key takeaways from our discussion on role-based access control, RBAC. The importance of RBAC cannot be overstated. It's essential for secure and efficient access management within any organization. When it comes to key elements, we need to focus on precise role definitions, adhering to the principle of least privilege, enforcing separation of duties, and conducting regular audits. These components ensure that access is appropriately granted and maintained over time. To effectively implement RBAC, follow these steps. Clearly define roles based on job functions. Create these roles within your system, assign them to users dynamically or statically as needed, and regularly review and audit role assignments to prevent issues like role creep. These practices help to streamline access management, enhance security, and support organizational efficiency. With the understanding of the significance and the key components of RBAC, let's move forward to our next steps. For further reading, I recommend RBAC, Concepts and Implementation by Thomas Ristenpart and the NIST SP 800-162 Guide on Attribute-Based Access Control. These resources will provide comprehensive insights and in-depth understanding. For practical support, you should start experimenting with setting up RBAC in virtual environments. This hands-on approach will help you apply theoretical knowledge to real-world scenarios. Additionally, joining IAM-focused security forums and discussion groups can be very beneficial. These communities are great places to seek advice, share experiences, and stay updated with the latest trends and best practices in access management. On this slide, we have a list of references that are essential for understanding role-based access control, RBAC, in more depth. The first reference is NIST SP 800-162, which is a comprehensive guide to attribute-based access control, providing detailed frameworks and principles that correlate well with RBAC concepts. Next, RBAC, Concepts and Implementation by Thomas Ristenpart is a valuable resource for diving into the theoretical and practical aspects of RBAC. This book is well regarded in the field and offers a solid foundation for implementing RBAC systems. The third reference, Implementing Role-Based Access Control for Secure Operations, published in IEEE Explore, offers insights into the practicalities of RBAC in real-world secure environments. It is particularly useful for understanding operational considerations. Finally, documentation from both Microsoft and Linux on user and group management is essential. These documents cover specific implementation details and best practices, helping you navigate RBAC setups within different operating systems. These references collectively provide a well-rounded foundation to both understand and implement RBAC effectively in various environments.